This is the 2010 free response questions, and I want to go over this with you so that you can check your work. I also, in some of the problems, I have pulled some actual student work so that you can see how the students would write their answers. In this problem that you've already done, you have snow going onto a driveway, and then you have the person shoveling it off of the driveway, and you have two rates that are going on. The first rate is the rate of snow going onto or accumulating on the driveway, and then you have a function called g of t that represents the rate at which snow is being shoveled off. So this is like our classic sand on, sand off problem. How many cubic feet of snow have accumulated on the driveway by 6 a.m.? This is a simple and a classic accumulate all of the snow that fell. So with your calculator, you would calculate that definite integral and make sure that you put the correct units and round off to 3 decimal places. In letter B, they're asking us the rate of change of volume. Now, we've done this a lot, and it's very important that you understand that we've got to consider the total rate. The total rate is comprised of two rates, and in this case, it's snow on minus snow off. So in this problem, we want to find the total rate at 8, so that's why they're taking f of 8, which is snow on, minus snow off, which is g of 8. Now remember, when you use your piecewise function, the number 8 is in this interval, so this is the function that you would use to find that value. And so it's just a simple subtraction problem. Again, it is a rate. Make sure you put the appropriate units. In part C, h of t is a brand new function, and h of t represents total snow. So we have to accumulate snow. So looks like we're going to have some integration going on here, and we're accumulating the snow that has been removed. So we're really focusing on the g of t function. In other words, g of t would be the derivative of h of t. It's how fast she's shoveling snow. And so they say, well, you know the g of t, you know the rate. Find for us the original function. Now, if your rate is a piecewise function, when you find the integral of that g of t dt, you're going to get a piecewise function. So you're going to find the integral of each individual piece of the function. So you'll find the integral of this, and of this. All right, so the first thing that we know is that, let's see, is there something else that they ask us to do there? Express h as a piecewise function with a domain of 0 to 9. Initially, at time 0, she has accumulated no snow. And at h of 6, so this is the important part that's going to make a difference here, she has accumulated some snow. So we need to know how much snow she accumulated at 6. And then we find the antiderivative of that. Now notice when you find the antiderivative, you don't have to write up all of this stuff in here. You could have done this, and you'll see the student work on this problem. Again, notice that they use a t here and an s here for two different variables, but we're finding the antiderivative of g, and since g is 125, the antiderivative is 125 of t minus 6. So we're evaluating that at 6 hours. Same thing going on with h of 7. Now, whether or not you showed your work or thought of it like that, this is the ultimate piecewise function that you end up with. So this is what you want to check your work with. Did you consider that you had to go from t or 6 to t, and from 7 to t. How did you know the variable was t? Because they asked you to find h of t. And then letter D is the how much snow ultimately do you end up with? Well, we need to first of all figure out how much snow actually fell, and then we need to take away the snow that we shoveled in that time period, which we're going to get from going back in here. Now, if you had the wrong function, now this is important, if you had the wrong function here, but you plugged in the right number, and they'll follow your work, and this is the answer that you get. Now, I'd like you to take a look at the student work for this problem. This student received 9, and I'm only looking at the piecewise part. So this is part C. I'm comparing 3 students' work. This student right here received all of the points, all 9 points. Now, the second student, I've highlighted what they say about that. The student earned the first point in part C for correctly identifying that h of t equals 0. In other words, they got this piece right. The second point was not earned since the student reports that the linear expression is 125t, and instead of that 125 parentheses t minus 6. The student did not use the initial condition that h of 7 is 125 and does not horizontally translate the linear expression. I know you don't know what that means. That just means they didn't consider the 6 and the 7. So many of you may have ended up with this function. Now, again, when you did part D, if you substituted the value of 8 in here, or 9, or whatever it was, you would get a different output, but based on your work, it would be correct. And then the last student, you can see, did not find any antiderivatives whatsoever, so they didn't get, I don't think they got any points as part C. Okay, well, they did get this point because they got the first piece correct. Okay? You may have more questions on that, but you can see me after the break to take a look at that. By the way, I hope you're having a good break. This is another classic problem. Remember, we just did the concert. Now we have people at the zoo, and they're sponsoring a one-day contest. Time t equals 0 is noon, so this would be 12 o'clock, this would be 2 o'clock, 5 o'clock, 7 o'clock, 8 o'clock. Notice right up front that these intervals are not the same. This is an interval of 2. This is an interval of 3. This is an interval of 2. This is an interval of 1. So the first thing they ask you is to approximate the rate. When we approximate a rate, we're going to use slope, average rate of change. We're going to go one above. We're going to go one below. Very easy problem. Please make sure that you put your units. Part B, they're very specific. They want you to use a trapezoidal sum with 4 subintervals, but remember that the subintervals are not equal. So this is a classic trapezoidal problem, and you would use your calculator to tally up your answer and then the final sentence. Part C, at 8 o'clock, volunteers begin to process the entries. They process the entries at a rate modeled by. So this is how fast they are processing those entries. According to the model, how many entries had not yet been processed? Now, this is a rate, but what we really want to know is how many. When you see the word how many, that should clue you in that you're looking for an integral, because we're trying to accumulate the entries had not been processed. Now, we need to know at 8 o'clock, after everybody came, how many entries were there. There were 23 entries, but we want to know how many they processed. So since we had 23 entries, we need to subtract all of the entries that we accumulated from 8 to 12, which gives me 700 entries. Okay? And then the last question, according to the model, at what time were the entries being processed most quickly? Extreme value theorem, ladies and gentlemen. Make sure that when you use the extreme value theorem that you set up a table. Also, make sure that you consider the end points and the critical numbers. This is a calculator problem, so you're going to take your derivative, p prime of t, set it equal to 0 with your calculator. Notice that you would store these numbers right here, and then you want to find out the entries, so you're going to substitute back into p of t, because we're finding we're really looking at a rate of a rate. And then you choose their processing entries the fastest at 12. You can see that that's the largest value. Okay, hopefully you can watch this at a rate, speaking of rates, that you can score yourself and see how you're doing. Here are just some information that they gave about this problem. The mean score was 2.60. That's really low. Out of 9 points, about 5% of the students, you can read that for yourself, In part A, what were kids successful doing? They said kids did a great job here. In part B, many students had difficulty giving an appropriate trapezoidal sum based on the tabular method. That means because it came out of a table. I guarantee you that a lot of students didn't use the right intervals. They made an assumption. In part C, most students set up and computed the integral, and many went on to give a correct answer. In D, students entered the problem correctly, but many of those students did not show justification to earn the justification point, and your table is an acceptable justification, the numbers in your table. What were the mistakes that students made? Some students seemed confused over whether E of t represented the number or the rate. This confusion affected their responses. In part B, a number of students inappropriately applied the trapezoidal rule, failing to observe the variable or changing widths in the interval. For the third point, many students had difficulty with the units. Average value. They forgot to divide. When you average your grades, you divide by the number of grades. In part D, many students earned the first point for considering whether the derivative was equal to 0. They often neglected to consider the end points. So what advice do they give to students? Based on your experience of student responses at the AP reading, what message would you like to send? Students should be encouraged to show intermediate steps. AP readers do not fill in the gaps in student explanations. The second bullet, it is important for students to understand a variety of methods when finding local maxes and mins. And lastly, students need practice communicating mathematics using clear, mathematical, correct, and mathematical language. In other words, they're just trying to say here, show you know. All right, you got it. Problem number 3. Let me see how my time is running here. I might have to break this into 2 videos. Okay, let's see. Well, I'll go as far as I can. All right, this is the concert problem that we did the other day. There's 700 people standing in line for a popular amusement park ride when the ride opens. The ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. The graph shows the rate at which people arrive. So there are 2 rates going on here. This is rate number 1. This is how fast people move onto the ride. And this is rate number 2. That's the arrival rate at the ride throughout the day. So again, remember, 2 different rates. How many people, this is an easy question, how many people arrive at the ride between 0 and 3? Well, if they're asking me how many, they want me to find a definite integral from 0 to 3. And they're asking me about arrival, so that would be of r of t dt. Now, the way we're going to do that, since we don't have the function, is we're going to go 1, 2, 3. And we're going to break this into regions that we can, now you can find the area however you want. I know that I'm not even sure. I think they did 2 trapezoids and doubled it or something. But you could, if you wanted to, you could have made it into like a rectangle here, and you could have made this into a rectangle, and this is whatever you want to do. What I would have done, I'm pretty sure, is I would have get my pencil again first of all. I don't know. I would have found this trapezoid number 1, and then I would have found this as trapezoid number 2. And now be careful, this distance would be these 2 would be the bases, and then this distance would be the height. So 1/2 of the height times the sum of the bases. Anyway, final outcome, don't assume that this, because you don't have this writing, if you have the 3,200 people and you correctly use geometry, then you're good to go. Second question, is the number of people waiting in line to get on the ride increasing or decreasing between 2 and 3? Now, waiting to get waiting to get on the ride. So part B, the number of people waiting in line is increasing, so they answered the question, because people move on to the ride at a rate of 800 people per hour. And from 2 to 3, so let's take a look at the graph up here. Get rid of this stuff up here. So we're looking from 2 to 3, and this is people per hour right here. And then the graph, or this is the graph, oh, come on. This is the graph that represents the rate of people arriving. So we know that the number of people waiting in line is increasing because people move on to the ride at a rate of 800 people per hour. And from 2 to 3, R of t, which is in red, is greater than 800. Okay? Part C, at what time is the line for the ride the longest? Well, in Part C, we know that the R of t, which is, here, let me go back and erase up here again. R of t is the graph. And we know that there were 800 people per hour at t equal to 3. So from 0 to 3, R of t was greater than 800. So that's what they're saying. You can see from here to here, R of t was always greater than 800. And then from 3 to 8, R of t was less than 800. Therefore, the line is longest at time t equal to 3. So it's like saying the people are increasing here and they're decreasing here, so the greatest occurs at time t equal to 3. What else did they ask me? How many people? So we need to accumulate all of the people that are in line at that time. So from 0 to 3, we're going to use geometry again and add up all of the people at t equal to 3. There are 1,500 people waiting in line. There's no way I'd wait in that line. Part D, write but do not solve an equation. They're telling you we want an integral of r whose solution gives the earliest time at which there is no longer a line for the ride. So, also, keyword, want an equation. So if there are no people in line for the ride, we want there to be 0 people waiting in line. So there were initially, this is our initial condition, 700. Then we need to add up all of the people that were waiting in line. Or is this waiting in line rate? I think that's the arrival rate, sorry. R of t is the arrival rate. Good. Arrival rate. Remember we talked about wax on, wax off? Minus the ride rate. That's how many people get on. And we want that to be equal to 0. Now you could have had your equation where you could have had negative 700 over here, or you could have manipulated it around. It doesn't have to be set equal to 0 if you have the same equation after it gets manipulated. Okay, let's go on to the next question. I might have time to get one more in. Okay, showed you some student work. This person scored a 9. Yeah, this person scored a 9. So I just want you to take a look at how a student wrote the answers to these problems. So part A, that one's pretty straightforward. They did geometry again, and they got their people, got the peeps. And then in part B, the rate of people arriving is greater than the rate in which people move onto the ride. Therefore, the number of people waiting in line is increasing between t equal to 2 and 3. Now, notice how this student just simply wrote it up in words. You don't have to get all real fancy. And then really I'm interested in part C. The line is the longest at t equal to 3, since from t equals 0 to t equal to 3, r of t is greater than the rate of people that move onto the ride. So from 3 to 8, r of t is less than the rate of people that move onto the ride. So that's what I'm showing you on the graph. And the lineup will be shorter. And again, I want you to see how this student just kind of writes a little paragraph that explains, this is what I'm thinking, this is how I came up with my solution. So I want that to kind of help you to see that you don't have to write up your answers with math ease, so to speak. You write it so that somebody can understand what you're thinking. And then in part, let's see, then she actually calculated the number of people, remembering the initial number of people. And then letter D, she made her equation. She figured out what she needed to do, and that's it. Notice, though, that she had a T and an X, a T and an X. Make sure that you make two different variables there. Hopefully this has been helpful for questions 1, 2, and 3 with the calculator. In the interest of time, I have to go to my next class now, so I'm going to have to stop the video, and then I'll do a separate 4, 5, 6 video.